Hi there, I'm Mr. Orr, and today we are going to be taking a look at Chapter 10, starting with Section 10.1. Chapter 10 is about circles, and Section 10.1 is a number of terms that you need to know, and then there's some information about tangents to circles. So let's start with the terms and the information that you need. A circle, to start with, has a diameter, which I'm sure you're familiar with. That's the distance across through the center. Half of that diameter is a radius. So the distance from the center out to the circle is a radius. The diameter is also a chord. And any segment that goes from, here, let's see if we can close that in a bit. Any segment that goes from a point on the circle to another point on the circle is a chord. So the diameter is a chord, but so is that, and so is that, and so is that. They're all chords. If you extend a chord in both directions outside the circle, then it becomes a secant. So we have a diameter, a radius, a chord, a secant. Let's see what else we have. We have a tangent, which is, let's erase this and make a new circle here. A tangent is a line that touches the circle at one point. Now, it can stop there, as in this tangent line right here, or it can continue like that, okay? But it touches the circle at one point. All right, let's go on to theorems in our book 10.1 and 10.2. Theorem 10.1 says, if a line is tangent to a circle, then it is perpendicular to the radius at the point of tangency. So if I left this lopsided looking circle here, and I drew a radius down to that point of tangency, there is a right angle formed by the radius and the tangent line. Okay. Theorem 10.2 is simply the converse of that, which says if a line is perpendicular to a radius at the endpoint of the radius on the circle, then the line is tangent to the circle. It is simply saying if you have a perpendicular line here drawn to this line, which is and it's perpendicular here at this point where the radius meets the circle, then this line is a tangent line. Okay? Now, there's another theorem. So the important point here, and the one that we will use most often, is that if you have a circle and a line drawn touching the circle at a single point, then the line is a tangent line, and if I draw a radius to that point, that's perpendicular. Okay, that's the important part. Now, we have one more theorem, which is not often used, but I'll mention it here, and that is that if you have a circle and you have two tangent, let's complete that circle this way, if drawn from out here, I have two tangent lines, okay, tangent here, then that's equal to that. All right. Those are the key points of section 10.1. There is a problem here that I want to do to make sure that you get this particular concept, and that is, if I have a circle and I have a radius drawn to here, and I have a tangent line drawn to here, and I make, now you know that the radius is perpendicular to the tangent line right here. Now, if you have, for example, this is an 8, and you are also given this as a 12, and you want to find, and this is a 16, and you want to find, let's see, is this going to work out or not? What am I trying to find here? No, that's actually not going to work the way I want it to. Let's try without the 16 here. Let's put, let's see, this we know is a 12, So let's put an x out here and see if we can find, no, that's also too easy. All right, let's try one more thing here. See if we put an r here, because those are both radii. And this is 16. Let's see if we can find r. So I'm going to do 16 squared plus r squared is equal to r plus 8 squared. Okay, so here's what we have. We have a right angle here. This is a radius, this is a radius. So I can say r squared plus 16 squared, those are the two legs of the right triangle, equals r plus 8 squared, which is this entire length, which is the hypotenuse. Now let's see what happens if we do this. 16 squared, which is, let's make that 256. 256 plus r squared equals, now this has to be FOILed, r squared plus 16x plus 64. Now, happily, the r squareds cancel. If I subtract the 64 from both sides, I get 16x is equal to 256 minus 64 is 192. And if I divide by 16, I get 1, 2, I get x equals 12, which we already knew because I'd set up the problem earlier, but in fact we found out that the radius is 12 by using a couple of things here, one of which is the fact that the radius and the tangent line are perpendicular at the point of tangency. That gave us a right triangle, which we could then use to find the value of r. All right. Let me see if there was any other problem here that I wanted to go through. I don't think so. In this particular section. We're going to move on to section 10.2. I'll be back. Thank you.